Welcome. This is the third video in the series on our introduction to statistics, and in this video we're also kind of beginning the topics in section 14.2 of your book called measurement. Our major goals are to cover a lot of vocabulary. One thing will be the target population of a study. We'll also talk about the different the strategy of studying a population from a sample, and make an acknowledgement of the regularly desired summary facts, just recognizing that we can kind of categorize them. And then we'll also actually get into how to collect samples, or the different techniques employed, and the different pitfalls that people run into when they're drawing their sample. So the first thing, though, is to define these words. And there's quite a few different words, and we'll try to make sure we piece them out. So we have the population, which is just any well-defined group of individuals. So any group that it's clear to say, oh, yep, that person is in or that person is not in, is a population. And it doesn't really even have to be people. It can be animals, or it can be inanimate objects. It can be tiles on a roof. But then when we're making a research study, we have a target population. So it's a well-defined group of people. That's what the population is. And the target population is the group that we're specifically trying to get information about. The sample is we're desiring to be a subset of the population or target population. Is a subgroup of the full group that we're trying to study. And then the sampling frame is a population in its own right, but it's not necessarily the population that we're trying to study. It's just the group that we are drawing our sample from. So to try to piece this out, let's draw a few bubble pictures. So the ideal setting, is you have a population, a target population, and then you have actually let's do this in this color. You have a sampling frame, which includes the entirety of the target population. That is, it's possible that any member of the target population could be sampled. So let's label that the sample frame. And then you just sample some subgroup. So there's the sample. So that's kind of the ideal scenario, that anybody from your target population could have been in your sample. You don't have time to grab everybody from the population. So you get a sample and you make a conclusion about the population from the sample. Then the kind of possible real life is you have some target population, and then your target population includes members of the sampling frame, but the sampling frame might go outside of the target population. And so there's individuals that you might sample that aren't actually in the population that you wish to know about. And so let's label that. So this will be our sampling frame. And so then it's possible that when you go to draw your sample, you'll actually get some individuals who aren't even in the population that you wanted. And you can imagine a situation where, I don't know, you're trying to study oysters in the Northwest. And there's two species of oysters that look really similar, but you're only trying to study one of them. So your target population is species A. And your sampling frame is all the oysters that are that you can have access to at a local farm. And so that's not all the oysters. So your sampling frame doesn't even include all of the oysters. But also, you might accidentally pick up some oysters from the different species and misidentify them, and then your sample doesn't actually include just oysters of the type that you're trying to study. So the real life is just much messier than the kind of ideal way to study, and it's just important to confront the messiness and the vocabulary words just allow us to communicate about that messiness in a little bit more systematic fashion. The other example we had is in our smallpox example. The 6,224 individuals, that was the sample. Everybody else living in Boston who could have been kept track of by the research, those are the individuals in the sampling frame. And our prompt here is to describe the population. And this can be tricky. Is it everyone in the world? Is it everyone living in a city? Or should we be even more specific, everyone living in Boston? And it's just a good thing to keep in mind because we want our results. It's a good thing to keep in mind what you're declaring your population to be, because your population is to whom you are applying your results. So in our study, we concluded that inoculation was a good thing. It increased the chance that you were going to be living. But does that mean everybody in the world needs to get inoculated? I mean, towards smallpox, people would probably say yes. But you just always need to ask this question: to whom do our results really apply? Maybe our study wasn't good enough to apply to everybody in the world. There's too much uncertainty, and so maybe it only applies to people living in cities. This is not an exact question. There's a desired target population that is wider than maybe what your target population is fair to say. The so-called scope of the study needs to be restrained to something that is reasonable. So, as far as our study went, it'd probably just be people living in a city or people living in Boston. Of course, the results would make you want to do a wider study and see if it applied to everybody living in the world, which, of course, we know that vaccines are highly effective for all people. Or most people. Okay, let's move on. A goal of statistics is to understand the accuracy of generalizing about a population made via studying samples, right? So this is in line with what we're saying here. How do we generalize the results that we get from our sample? Some more vocabulary. The parameter is the summary fact about the population. So that's in comparison to the statistic, which is the summary fact about the sample. So when you study a population, you want to know the parameter. Due to limitations of economy and time, you rarely have the opportunity to take what is called a census, which gets information about a population. Instead, you study a sample, and the fact that you gather from the sample is called the statistic with a lowercase s. And you use the statistic to estimate the parameter. So statistics always used to estimate a parameter. Parameter is something you rarely ever know. You can never freeze time and ask everybody their opinion. You always are just grabbing a statistic and using it to estimate the parameter. So we've already met all of the common statistics. We've talked about enumerations in the previous videos, and averages, medians, and proportions have come up earlier. But they're just numerical summaries about a group of individuals. And they're all one number, but they're attempting to summarize information about an entire group. So we got this other example: the proportion of people who died of the 5,980 people who were not inoculated is a statistic. The corresponding parameter would be the proportion of people who died portion of all people who died given that they were not inoculated. So there were more than 5,980 people in Boston who were not inoculated. So we're actually even, in answering this, we're thinking more of the population as everyone just living in Boston. And we're saying, okay, so there were more than 5,980 people who were not inoculated in Boston. What is the proportion of those people who died? Because we only know about the 5,980 people that we kept track of. And here's a final question that is a little bit less morbid. And suppose you want to know how long it takes to finish a degree at Portland State. What would be your population and what might be the parameter? Right, so like imagine that you are having to fill out, you're going to create a brochure that says it takes this long to finish at Portland State for maybe incoming freshmen. So your parameter is likely an average. Right, you'll probably want to say the average number of years it takes. The average number of years it takes. Although you could make an argument for a median. And you could also make an argument for proportion, the proportion of people who finish within 6 years. So it's just important to identify kind of what you are after. This is a part of that conversation of how to make a good research question. What you want to say, how long does it take to finish a degree at Portland State? That's great. What information do you want to use in order to report that information? What information do you want to say in order to report this idea of how long it takes to finish? Because how long does it take to finish a degree at Portland State? Because there's an ambiguity in this question. And then finally, the population might be population that you're going to study might be everyone who has graduated in the last 5 years. And making your population as specific as possible is kind of the takeaway here. You don't want to just say the population is everyone who has graduated and just leave it at that, because Portland State's been a university for decades, and the amount of time that it takes to finish a degree now is probably different than the amount of time it took to finish a degree 30 or 40 years ago. So this choosing of the 5 years is, maybe you ask, like, well, how do you choose in the last 5 years? And maybe you don't. Maybe it's in the last 10 years. But at some level, 15, 20, 30 years, the information seems to get a little bit outdated. So you have to make a decision there. And it's just important to report exactly who you are talking about. I studied people who graduated in the last 5 years. I didn't estimate people who are still in school, who are telling me when they think they're going to graduate. I have certainty about who my population is, and here I am communicating it. And that's kind of the takeaway here for how a research study should be done. All right, so we covered a lot of vocabulary in this video, and we'll be using it regularly, and it will become more normal to you, and as we progress into the next videos. So I'll see you there.